Good morning, Algebra 2 students. This is Mr. Myers, and I'm going to go over rational functions. But before we start on specifically talking about the parts of a rational function, I want to define a rational function for you. So here we go. If I have f of x is equal to x minus 2 over x squared plus 7x plus 10, that would be a rational function. Remember, a rational number is a number that can be written as a fraction. It doesn't necessarily mean you have to write it as a fraction. It just means that you can. So a rational function can be written as a fraction. So I have the rational function x minus 2 all divided by x squared plus 7x plus 10. Now, the first thing we want to talk about in graphing this function are its asymptotes. You can have a vertical asymptote. Ooh, I don't know what happened there. My screen kind of flickered on me. Or you can have a horizontal asymptote. A vertical asymptote is an asymptote that is defined by a vertical line, x equals a number. And a horizontal, and I'm having trouble spelling the word horizontal, is one that is defined as y equals a number. So let's finish off. I know I misspelled horizontal. We'll clean that up later. Okay, so a horizontal asymptote is one, y equals some number. And when we do that in Desmos, and you'll see that shortly, it's going to create a line that has no slope and goes on forever in each direction. And if you click on the line and drag your pointer back left or right, you'll see that the y value of the line never changes, but the x value does. And that's why we don't have to write an x here. We could put, you could literally put 0 times x, because whatever number you pick for x, you're going to multiply it by 0. So that's going to equal 0 plus whatever you choose, or not choose, whatever number makes the horizontal asymptote approach, the slope, whatever makes the curve, whatever line the curve is approaching but not touching. We'll talk about that when we get there. Okay, first thing we're going to do is look for vertical asymptotes. They're the easiest ones to find. So how do you find a vertical asymptote? Well, the first thing we have to do is factor this. We have to factor the denominator. Vertical asymptotes are defined as lines that, they're defined as the x values in the denominator that would potentially make the denominator go to 0. Now, just because you find a number that makes the denominator go to 0 does not instantly make it an asymptote. That's why we're going to graph it. Later on, there are ways to algebraically figure it out if it's an asymptote or not. But in our class, once we find the possible vertical asymptotes, we graph them to determine whether they are or they're not. And I'll show you an example of each one. So to factor this denominator is pretty simple. It is a quadratic, a trinomial. So I use my x method because it's going to work very well for this particular trinomial. And we have b up top, we have c down here, and I need two numbers. When added, make b. When multiplied, make c, and that will be 5 and 2. 2 times 5 equals 10. 2 plus 5 equals 7. So my factors are going to be x plus 2 and x plus 5. Now, these are my possible vertical asymptotes. Now, understand, one of the common mistakes that students make is they see this plus 2 and they think that the asymptote is at positive 2 and positive 5. You always have to ask yourself, when you have a parentheses with an x in it, what number would make the parentheses go to 0, not what number is being added or subtracted to x. So my potential asymptotes are x equals negative 2 or x equals negative 5. Now, how do you determine that? Well, we go over to Desmos. So I already have the function here in Desmos, and you can see what it looks like. It has these curves, and you can already tell there is a horizontal asymptote right there at y is equal to 0, but we haven't gotten to the horizontal asymptotes, so I'll leave that for a little bit later. What we're looking for is the vertical asymptotes, and we said the potential asymptotes are x equals -2. Oops, hit an extra 3 there. And also x equals -5. And if we zoom in a little bit, we can tell that those are horizontal asymptotes because as you see this green curve coming down, it's getting really close to the red line, but it's not going to cross it. The same here with this green curve on the left side, it's getting close to the blue line, but it never touches it. If we go up higher, you can see there's this little piece of the graph up here. Same thing with those two curves. It's getting close to the red and blue lines, but it's never going to cross it. So we have determined that there are two vertical asymptotes, one at x equals -2 and one at x equals -5. Okay, I'm going to stop right there and I will pick it up on the other side talking about horizontal asymptotes. So until the next one, have a good day and we'll see you in class.